All right, thank you so much for joining us today. So this will be the last video on limits. So we are going to take this sample questions, and then in the next video we are going to talk about derivatives, right? So let's go through very fast. There are 14 questions, so let's go through fast. We want to find the constant c that will make the function continuous at x is equal to 2. So we remember continuity, and I gave you the trick, or the, let me say, the tip, that anytime you are dealing with something like you are finding a constant, look at what is here. Check whether it is less than this kind of sign or it is this and that. So we said whenever you have this one, you need to use the left and the right, and whenever you have this one, you need to use the third property of what? Limit. So it means that here we need to use the third property of limit. What's the third property of limit? We want to use limit as x is approaching a of f of x, and this one should be the same as f of a. So because the function is continuous at 2, so this is what we need to talk about. And here our a is what? 2. So we want to look at limit as x is approaching 2 f of x, and this one should be the same as f of 2. So that's what we just want to do. So the first question is, what is f of 2? F of 2 here, this is kind of the same as f of x is equal to 2. So what is here is our x. So look at the function where x is equal to 2. X is equal to 2 is here, and the function is c. So this is equal to c. So what we just need to do is now we need to find the limit as x is approaching 2. So let's do that. Limit as x is approaching 2 of f of x is the same as limit x is approaching 2. Now, anytime you have this not equal to and equal to, the limit aspect is where the x is not equal to, right? So x is not equal to 2, it means that we need to use this one. So we are going to have x squared minus 4 divided by x minus 2. As I said, anytime you are dealing with limit, first direct substitution. But if it is a rational function, look at the denominator. Put 2 here will be 0. So it means that direct substitution is not going to work. So let's try and simplify. This is the same as the top is x minus 2, x plus 2. That's the difference of 2 squares, right? And this will cancel that. So we are going to have limit x is approaching to x plus 2. Now we can after simplification, we do direct substitution. So here we set x is equal to 2 because x is approaching 2, and we have 2 plus 2, and this is going to give us 4, right? So it means that c should be 4 because we are saying that f of 2 should be the same as this limit. So since this is c and this is 4, we are going to have 4 is equal to c, and our c is going to be what? 4. So like if we become very good, it's kind of very simple to go through the whole question very, very fast. Good. Now let's look at this limit here. So we talk about one-sided and two-sided, and I talk about this function. So we said absolute of x is actually we can have a piecewise function. We can have the negative side of x and we can have the positive side of x. Then when you finish, you pick the function inside the absolute and you say that it's greater than, this one is minus, so it should be less than 0. And then the same function inside the bracket again, we are saying that this should be greater than or equal to 0 because this is positive. Then when we are done, since we've gotten this, we need to manipulate this function in a such a way that it suits what is here. So we've gotten the top. Now for us to get the down, we need to divide this one by 2x. So the next step is to divide this by 2x. And as we are doing it, you need to affect this function too as well. So I'm dividing minus x by 2x. X should be less than 0. And same thing for x divided by 2x, and x should be greater than or equal to 0. So what am I going to get from here? This is going to give us, so yeah, so this one I need to take 0 out because if I include 0, when I plug in 0 here, it becomes undefined. So I can just exclude 0 from there. And then here, s cancel x, I'm going to have minus 1 over 2. X is less than 0, and this is 1 over 2, x is greater than 0. So this is the function that I'm going to have. And we can see that now this is the original function that we have in here. This is the one that we are having. So what's the question? The question is asking us to find limits as x is approaching 0 from the negative of absolute of this divided by 2x. So what is the function for when x is approaching 0 from the negative side? So negative side, it means that all the values of x are less than 0. So indeed, it's this one, and the function is minus half. So we are going to have minus half here. And we know that limit of a constant is the constant. So this is going to give us minus half, which is indeed this one here. So for us to do this, we needed to build this function before we can do this. Now, what will be the shortcut? I will show you the shortcut. Here, if you are doing it and you don't want to go through this process, since it is section A, then what you just need to do is, anytime you are doing this, this is the shortcut. So let me show you the shortcut. Okay, I have the solution, so I can just write it here. So this is the shortcut. Limit x approaching 0 from the negative absolute of this divided by 2x is equal to, now write this one as limit x approaching 0 from the negative. So this is how you need to see it. Since this is negative, telling you that it's negative, take the absolute and replace the negative there. That's all, because this is negative side. So this is going to be minus x divided by 2x. X will cancel x, and we have limit x is approaching 0 for negative side minus 1 over 2. And you see that this is 1 over 2 without going through this. So that's what you need to remember. If this is minus, then it means that absolute, we know that absolute has positive and negative. So look at the sign here and choose it with this. So when we get another question which goes with absolute, I will just go straight using the trick. Good. For example, this one. So I'm not going to build the piecewise function again. So you can go through the same process if you want to build a piecewise function to help you. But I'm just going to use a shortcut. So this is what I'm going to do so that I finish the question and then I do other things. Limit x approaching this minus that. This x minus 12, absolute of x minus 3. This I'm going to choose, since this is negative here, I'm going to choose the negative side of the absolute sign. So negative of the absolute. So 4x minus 12 divided by x minus 3. Now somebody is asking, what if it is positive? Then you choose the positive side. So this is what I'm going to get without building the piecewise function. So this is kind of, it will save me time solving this basically. So now I can factor 4 out from the top. So I'm going to have minus 4x minus 3 divided by x minus 3. And the magic happens, this one will cancel. And then limit as x approaching 3 from the negative side is just minus 4. Limit of a constant is still the constant. So this is going to give us minus 4. So you see that this is very simple. But if it is section B, then we need to build the piecewise function and use the piecewise function to solve, right? Basically, that's how it's supposed to be. Now let's look at question 4. So find the limit of this as x tends to 2 from the left. So that is, this one was written in left. We want to find the limit as x tends to 2. It means that x is approaching 2 from the left. So this is the question that is asking. It's asking us to find limit as x is tending to 2 but from the left of f of x. So instead of writing this one for us, they wrote it in this form. So this minus here means that all the x values are less than 2. So let's go to the function. Which one is less than 2? Is this which is less than 2? So we need to use this function. So it means that this is the same as limit s is approaching 2 from the left, 1 plus x squared. And then here we set x to be equal to 2. We don't consider this again. So this is going to be 1 plus 2 squared, which is 1 plus 4. And this is going to give us 5. So we have this one here. It's kind of very nice. Now we want to solve this one too. Limits x is approaching 1, x minus 2, x squared minus 1. Sorry, minus 4. So as I said, always direct substitution first. So let me plug 1 here because that's what is important. 1 squared is 1. 1 minus 4 is minus 3. It's not blowing up, so I can set s equal to 1 and do direct substitution. Minus 2, 1 squared minus 4. This is minus 1 divided by 1 minus 4, and this is going to give us minus 1 divided by minus 3, and this is 1 over 3. So this is kind of something like this. So you see that anytime I'm doing something like this, I'm thinking of, okay, what is happening next? Is it going to blow up, so that you save some time? Good. So this one, direct substitution, was working out. Even though when you simplify, it's also going to work out. But you see that seeing that you can use direct substitution was a nice way of getting this one done fast. Okay, let's solve this one. Limit x approaching 0, tan of x divided by 2x. So we know that we said that we have a property that says that limit as x is approaching 0 of tan x divided by x is equal to 1. Now remember, always the angle here should be the same as what is here. So here is x, here is x. So since this one is x, we just need x here, so we can factor this one out. So this is the same as 1 over 2. Remember, this one is at the denominator, right? So it means that 1 divided by 2 out, and it will be left with limit x approaching 0 tan x divided by x, and this is going to give us 1. So I'm going to have 1 over 2 times 1, and I'm going to have 1 over 2, which is here. So we are playing around how to be doing this kind of limit functions. They are very simple, very, very simple. So x squared minus 4x plus 12 divided by x minus 4. Rational function, think about the denominator first. Plug in 4 and it will be 0. So it means that we need to think about simplification. Let's try and simplify the top and see. I'm going to use x squared minus 7x plus 12. Two numbers that when I add, I'll have minus 7, but multiply and get 12 is 4 and 3. Good. So this one can be written as minus 3x minus 4x plus 12. And from the red side, I'm going to have x out, x minus 3. And then from the blue side, when I factor minus 4 out, I'll have minus 3. So it means that this is the same as x minus 3, x minus 4. Good. So we've simplified the top. So this is the same as limit x approaching 4, x minus 3, x minus 4 divided by x minus 4. Then the magic happens. This will cancel that. Limit x approaching 4, x minus 3. Plug in 4, 4 minus 3, and this is 1. So very simple, right? Good. Very good. Now let's look at this one. Good. I think this one is almost the same as this, but this, we look at the denominator. X is approaching 5. Limit as x is approaching 5, x squared plus x minus 20 divided by x minus 4. Think about the denominator. Set s is equal to 5. Put it here, and you are going to get 1. So it means that we can do direct substitution here. So this will be 5 squared plus 5 minus 20 divided by 5 minus 4. So 5 squared is 25, and then 5 minus 20 is minus 15 divided by 1. The top is going to give us, I think 10, right? Yeah. So this is going to give us 10. So always, like, you are trying to figure out what to do, and looking at the function, this is what's going to help you to do the thing very well. So now we've mastered limit, you should be able to doing a lot with limit, and it's kind of very simple for us to go through the question. So anytime I'm solving quiz or limit question, you know that you are going to get them 100%. Now let's look at this one. Limit x is approaching 4, 2x squared minus 3x plus 4 divided by x plus 5x minus 4 divided by x. I'm worried about the denominator. The denominator is x. When I plug in 4 here, I'm not getting 0. So I'm not even concerned with doing simplification. I'll just set x to be equal to 4 and put them in. So I'm going to have this one to be equal to 2 times 4 squared minus 3 times 4 plus 4 divided by 4 plus 5 times 4 minus 4 divided by 4. We don't concentrate on the numerator, or let me say the top, because if the top is 0 and the down is not 0, we are going to have an answer called 0. So we don't concentrate much there. So this is 16 minus 12 plus 4 divided by 4. This is going to be 20 minus 4 divided by 4. This is going to give us 32. This is going to give us minus 8 divided by 4, plus this is going to give us 16 divided by 4. 32 minus 8 is going to give us 24 divided by 4, plus 4 for 16. 4 goes to 24 how many times? I think 6, right? Yes. Is that true? Yes. Plus this, and this will be giving us 10. Is that true that let me check, because we are not having 10 here. 4, 5, 20. So 4, 6 should be 24. This one should be 10. Let me check if I made a mistake somewhere. So plugging in for 4 squared is 16. 16 times 2 is 32. This is 12. 4 from this one is going to give us minus 8. Minus 8 from this should be giving us 24. Yeah, that's true. And then this is 20 minus 4 should be giving us 16. And okay, so we don't have the option in here. We don't have the option in there. So that is okay. That is okay. All right, so let's look at the next one. The next one, we want to look at limits x is approaching 1, root of x3 divided by root of 1. Root of, x. So as I said, anytime you have a radical function 2, you do direct substitution first. So let me set x equal to 1 and see if I'm going to get 0. When I put 1 here, there's no way this is going to be 0, so I can do direct substitution. So root of 1 to the power 3, root of 1. This is 1 to the power 3 is 1, root of 1 is 1, root of 1 is 1 divided by 1, and this is going to give us 1. Very simple. So some of them, don't get scared, just be doing them and then you are good to go. Okay, I think this question was the one that we did the left side on the, I think that was the first question. So this one, you see that if it's a quiz, very quick, limit x is approaching 0, absolute of x divided by 2x. This is the same as limit x is approaching 0 from the positive. So since this one is positive, I need to choose the positive of the absolute, which is like x, right? Divided by 2x. X will cancel x, and limit as x is approaching 0 from the positive will be 1 over 2, and this is going to give us 1 over 2, right? Which is A. So we saw from the question 1, which we had coming, question 2 rather. Question 2, we saw that we had half. And when we look at the piecewise function, when x is approaching this one, we have half. And that's what we had from the question that we just did. So you see that it's kind of like smart way of doing the limit, and then you'll be able to figure out all the functions that you need to do. Same thing for this one. I think this one we did the left, and then I use the shortcut. So let's go through the shortcuts. X is approaching 3. No, since you know the shortcut, I want you to do this one and leave your answer in the comment section. Let's see what you are going to get for question 12, right? Leave your answer in the comment section. And then I think this one too, we've done it, right? This one is asking us to find limit as x is approaching 2 from the positive, because it is right, of the function f of x. So x is positive means that all the x value is greater than 2, which is here. So we use this function. So this is limit x is approaching 2 from the positive, x cubed. We set x to be equal to 2, and 2 to the power 3 will be equal to 8. So this one has no option also there. Let's do the last question, and then we are out from this here. So the last question Should I even leave the last question for you to do? Yeah, I think it's kind of very simple for you to do. Yeah, so basically I will leave you the question 14. I think, yeah, that's the last question. Let me leave you the question 14. So do the question 12, put your answer there, and do the question 14, and also leave your answer in the comment section. So in the next video, as I said, we are going to talk about um, derivatives, right? So please make sure you go through all the derivative videos, or hey, I said all the derivative videos, all the videos that we've done, coordinate geometry, circle, and we are now done with limit. We are going to start with derivatives. So make sure you get some time to watch them. They are very useful, to help you to understand it. The idea about math is when you understand it, now things become a little bit easy for you. You find your own way of what learning, right? And I always tell my student that if you were a math student and you become very good with math, it means that other courses to become very bonus for you, because it makes you very smart, and then it helps you to also navigate through other courses very well, similarly like math. So see you in the next video where we are going to start derivative.